Hi Ryan, this is Pushao. Sorry for taking so long for me to get this file to you. First was my sister and her 2 young kids visiting from Houston, my mom from Hong Kong. And of course every day we spend the whole day at Disney, and by the time we get home we're exhausted. Let me open your email and read up the questions that you sent me from the email. Your first question to me is that, what do you think is the reason the antibacterial crisis exists? The antibiotic resistance superbugs, I would say, call them superbugs because I want to include bacteria, fungi, viruses, and parasites into all of these superbugs. For the sake of convenience, for the easy discussion's sake, we are going to focus on the bacteria on this recording. The reason is simple. It's really Darwinian evolution. Each time an organism divides, there's a chance of mutation. And mutation will allow the organism to develop new tools to fight against either naturally occurring or man-made antibiotics. The time that takes human to produce the next generation is about 20 to 30 years, but bacteria only take about 20 to 30 minutes for them to have a whole new generation on average. And you can tell easily how fast they can develop through mutation resistance. And bacteria already coexist with us for a long time. They actually existed way before us on this earth for about 3.5 billion years. And the first time we developed antibiotics was nearly 60, 70 years ago. So bacteria really have a lot more armamentarium in their pocket to deal with the antibiotics that we produce, man-made. But I mentioned the naturally occurring antibiotics. They exist in the wild, and the resistance to these naturally occurring antibiotics are also naturally existing in the wild, and they can be shared. The resistance can be shared between species, and the resistance genes can be even found in ice core or caves that no human ever entered before. And not all microorganisms are pathogens. Only very small percentage of them are what we call pathogens, when they have the virulent factor that could cause diseases, and it would stimulate our immune system to detect and track them down and kill them. But most of the microorganisms are really colonizing our body. The microbiome, we call that, they exist in our GI tract, our skin, and mucosa. They do a lot of good things, making vitamins, helping us to digest food, and they even instruct the immune system how to function properly. And they also make natural antibiotics. So when humans use man-made antibiotics to kill certain pathogens, it's easy to have friendly fire or collateral damage to take out the normal flora. So there's a book by Dr. Martin Blaser. It's called Missing Microbes. It's very much worth reading. The healthy person may walk around with Staph aureus or even C. diff in their system and not getting infected. The infection means they spread deep into our body. So if these pathogens are really existing on our body, inside our body, and not causing diseases, then they're innocent. We don't need to eradicate them. And when we have normal immune system, they're just there. On the other hand, if they start to invade our system, then cause infection, then we use antibiotics to deal with them. And the earliest antibiotics is penicillin. It destroys the bacteria's cell walls. The whole group is called the beta-lactams. The bacteria are able to produce the resistance by producing what's called lactamase. They reshape their molecules so that they can resist the destruction by the penicillin. And there are thousands of genes that can produce different kind of beta-lactamase, and they confer resistance to penicillin. I wanted to say that I am a cardiologist, and I've been doing cardiovascular disease for 25 years, and I have not been that deep into general internal medicine. And ID to me is, I am not an expertise in ID, but I can tell you what I know. Let me quickly talk about how the penicillin was discovered. Alex Fleming in 1928 accidentally discovered penicillin, and he actually was the first antibiotic steward That means he understands the proper use of antibiotics in order to reduce the chance of antibiotic resistance. It takes about a decade for the penicillin to be mass-produced. Fleming's is the first one describing antibiotic resistance. It says if we use too little a dose or too short a period of time to treat a person, then the microbes are educated to resist penicillin. And he even said that the thoughtless person playing with penicillin is morally responsible for the death of a man who succumbed to penicillin-resistant organisms. See, he already realized that when antibiotics are used, they should be used properly. In 1950s, there were dozens of antibiotics were discovered, and half of the antibiotics that we are using today are actually discovered during that decade. So it was a golden era of antibiotics discovery, R&D, and production. By the end of 1960, though, the shift of the pharmaceutical companies were starting to be more toward the lucrative drugs such as heart disease and cancer, but we'll talk about that a little bit later. So let's go back to, in our bodies, how trillions of bacteria are waging warfare all the time. Survival of the fittest really is playing out every day, every minute in our body. They produce naturally occurring antibiotics, but they are able to reach an equilibrium. However, when we develop antibiotics on a mass scale, for the first time, bacteria are targeted, pummeling our microbiome again and again. And that is producing a lot of collateral damage to the friendly microbiome, which in turn would interfere the proper functioning of the immune system. As I had mentioned earlier, some of the microbiome in our system, in our body, is really crucial in instructing our immune system to function. The gut microbiome itself, the cells outnumber our body cells 10 to 1, and their genes outnumber our genes by 100 to 1. So we are almost the platform that bacteria are ruling the world. The second question you ask is that how serious or is the crisis being over-exaggerated? I would say we are not talking about it enough. It is estimated by 2050 there will be more people dying from antibiotic-resistant bacterial or fungi infection than heart disease and cancer caused. And even from day-to-day practice, I can see that it's easy for hospitals underreporting these problems because even the most sophisticated hospitals, even if they are the expert of treating the most difficult resistant bacteria or fungi, they are, or at least the administrators would have a little bit concern or worry that they could be labeled as an institution that infested with the scary resistant bugs, superbugs. So, and there's no federal law to say all hospitals have to report certain resistant superbugs. There's so many resistant Enterobacter, C. diff, gonorrhea, TB, a lot of the Staph aureus strep, they're all resistant. When simple infections or simple skin cuts, appendix can cause so much infection that can cause death. Even with anesthesia, we are able to do surgery, making sure patients are in relative comfort during the procedure, but we are not able to prevent or control the infections afterwards. Then that could mean the end of modern era. You are not able to even change a joint or doing C-sections safely without infection. Patients who are on hemodialysis 2 to 3 times a week are not able to have that done without risking infection. Transplant is out of the window because when you do organ transplant or bone marrow transplant, you have to use either immunosuppressant to reduce the strength of the immune system to target the new organ. But at that time, your body is at risk of acquiring infection. The opportunistic infection, very easy to spread throughout our body when anti-rejection medications are weakening our immune system. So without strong and effective antibiotics, and when the bacteria are antibiotic resistant, then we are not able to use the immunosuppressant to treat patients who have organ transplantation. Stem cell transplant, the same thing. On the other hand, when antibiotics are being used indiscriminately, the normal environment of microbiome in our GI tract is disturbed, it is associated with a lot of autoimmune disease, allergy, obesity, the ulcerative colitis, irritable bowel syndrome, even Parkinson's disease, depression. All of that are more and more data supporting their connection with the interruption of the microbiome in our GI tract partly due to the usage of antibiotics inappropriately. And there is a US map that I have seen that plotting the spread of antibiotic resistance and plotting the obesity, and it's amazingly overlapped. That means the places where incidence of obesity is the highest, those are also the places where antibiotic resistance the incidence are highest. And it is hard to imagine a post-antibiotic era that will essentially becoming the pre-antibiotic era, that 90% of children with meningitis would die, and those who survive would live with severe lasting disabilities such as deafness, mental retardation, and we are not able to treat strep throat. We'll have more amputation because of simple infections of the limbs. You see, when you watch those movies, the historical movies, it would show so many people who are missing a limb, and that is a lot to do not just because of trauma, but also simple infections of their legs could spread very easily, and without antibiotics, the only way to prevent the bacteria getting into the bloodstream and causing sepsis and killing a person is to amputate the limb. So without effective antibiotics, we'll live like that again. Simple ear infection of children can spread into the brain and cause death. Puncture wound, if you work in the garden and have some skin infection, it can spread easily. Would just make it very difficult for modern medicine to continue to be modern medicine when you cannot do simple surgery or have very high failure rate with all the simple surgeries. Currently, the most commonly encountered resistant bacteria are the carbapenem-resistant Enterobacter or Klebsiella. There are MRSA. For some area, 80% of gonorrhea are resistant to Campylobacter. Strep throat TB. There's some area in the New York State, E. coli that cause UTI. A third of the E. coli are resistant to Bactrim. Not all hospitals are reporting the resistant superbugs reliably, and some of them are afraid that the patients would become scared or spooked, that the patients do not want to go to the ER, and that could cause more health hazard when people in the community are scared to seek health care because of their fear of getting infection of the superbugs. We are really losing the PR battle here, where the kind of hospitals that have the most expertise are the most afraid of being labeled as being infested with superbugs. And many community hospitals, they may not even have the expertise to make the accurate diagnosis of the superbugs. And they are not underreporting, they're really missing the diagnosis. When you hear some places or some hospitals, smaller hospitals, say that they have very low incidence of superbugs, don't get happy yet, don't get too optimistic yet, because they may have just a poor diagnostic skill or expertise to recognize the true incidence of the superbugs. And the third question you ask, with the ongoing opiate crisis in the United States, in my opinion, do I believe that the antibiotic crisis would reach the magnitude of the opiate crisis? Well, I'm no expert in either antibiotic-resistant bacteria or the opiate crisis, but during the election season, I always am surprised by how lack of discussion of such serious issues that we are facing. Most of the voters would focus on economic development. The second most important issue during the election is the national security. So they vote for their personal financial future, jobs, and they vote for homeland security. That kind of issue would attract a lot of attention. But I would say that superbugs pose threat to both the personal financial future and the national security. And even when voters think about healthcare, they really think about healthcare insurance coverage. They're not really thinking about the ability of us dealing with the superbugs or opiate crisis. So I would say that we should discuss about these two areas a lot more during each election. The fourth question you ask, how much influence do you believe the U.S. healthcare has had on creating the antibiotic-resistant bacteria crisis? I would say a lot. But don't forget, there is also the whole industry, the farming and agricultural industry are playing a role too. But let me talk about both, even though you just asked about the healthcare section. First, the healthcare R&D, the research and development of antibiotics, the pipeline is dwindling, really to the point that it's really trickling at this time. When a new drug is discovered, the patent for the molecules will be only 20 years, and the research and development would usually take about 10, 11 years. And that means if this product is successfully brought to the market, it may have only 9 years to recoup their R&D expense, because R&D already take up 11 years out of that 20-year patent. On top of it is the concept of antibiotic stewardship. When you prescribe antibiotics, you usually prescribe, I'm talking about outpatient oral antibiotics, about 5 days to 10 days. And you compare that to a lifetime or long-term usage of medications for, say, hypertension, diabetes. There are many chronic disease requires a long-term therapy, whereas antibiotics, each infection you try to use for a short course, enough to cure the infection, but not too long to create or encourage resistance. Pharmaceutical company already looking at naturally a shorter course of each time their medications are being prescribed, and also more and more stewardship that is here now in each of the healthcare institutions. The healthcare institutions such as hospitals or nursing homes started to use stewardship or antibiotic steward because they try to limit the overprescription of the antibiotics, and they try to limit the emergence of resistant or superbugs in their institution. And in general, it takes about $1 billion to have one medication go through R&D process over that 11 years and successfully being brought to the market. And naturally, the pharmaceutical companies have to consider the future cash flow against an R&D cost. Antibiotics typically would cost negative $50 million per antibiotic discovered, and they do not want to have such poor investment. And it's understandable that they turn their focus toward more chronic illness or the diseases that people who are willing to pay more for. For instance, a person would feel reasonable, or they think the price tag of a special chemo medication that sometimes may just prolong their life by a few months, they still think it's reasonable to pay for thousands and thousands of dollars for those cancer medications, but they would think that paying more than a few $100s for antibiotics is ridiculous. So in general, publics would not accept a higher price tag for antibiotics. So even if you convince or the government allow the pharmaceutical companies to increase the price of their antibiotics in exchange for their willingness to research and produce them, the market would not accept that. Antibiotics was first started to be produced in late 1940s after World War II. The first was penicillin, like I mentioned earlier. And during 1950s to 90s, per year, there are approximately 3 new antibiotics produced. But now, not even one new every other year. So it's a whole 6-fold reduction of new antibiotics that is being produced. And at the same time, the old antibiotics are being withdrawn or becoming obsolete. 2 times of that of the discovery of new antibiotics. So the arsenal is reducing rapidly over the past 15 years in fighting against infection. And this rapid reduction of the new antibiotic pipeline can be explained by several ways. One is that the low-hanging fruits are picked already. And the second reason is that the large amount of resistance. If you use antibiotics to sufficiently eradicate an infection, you may need to use a very large dose. But this large dose may not be safe for human. It may be strong in killing bacteria in a petri dish or agricultural environment, but cannot be used in healthcare. Or certain antibiotics are strong and effective killers on a petri dish, but when you try to produce them into a pill, a tablet, or intravenous form, it is difficult to be delivered to the target organ or area to fight infection in the human body. And after facing all of these difficulties, even if a pharmaceutical company is able to produce an effective antibiotics, the current medical logic is that to hold this new drug in reserve until there's crisis, because we don't want to use a very valuable new antibiotics to treat the easy infections, because the more you use it, the faster the resistance would occur. So you try to save it for serious infection. Then you can imagine the drug company would not be able to sell these antibiotics in a large scale, not large amount, and they may not be even used right away. Whereas when you produce a cancer-fighting medication, the day it's approved, you can start selling it. The holding the most valuable or newest antibiotics in reserve would eat up the 8 to 9 years of patent time easily. Remember that the patent is granted to new molecules for 20 years, and in this 20 years, about 11 years are being already used in the research and development phase. So after the clinical research, first the basic research, the bench research, and then the clinical research of phase 1, 2, 3, then the new drug will have only about 9 years of patent after its approval to recoup the money. And now you're holding it in reserve, then every day the clock is ticking every day before it becomes generic. And therefore, the antibiotic stewardship, or the appropriate medical answer to or delay the resistance, is by reducing the frequency of usage of these strong antibiotics. But it is a terrible, terrible business idea to the drug companies. So summarizing what I said above, the current lack of new antibiotics is twofold. The reason is twofold. One is by the end of 1960s, the drug companies shift their attention to more lucrative drugs, such as heart disease and cancer, especially after Nixon's declaring war on cancer in January 1971, the new National Cancer Act. The second reason is the very recognition of the antibiotic resistance. The more we realize all antibiotics, no matter how strong they are, it takes about 5 years for resistance to occur. It always happens, and the drug companies know that they have only that short period of time to use this, to sell this drug before it becomes useless due to resistance. Yet, during that period of time, these new medications are mostly held in reserve by hospitals, by the antibiotic steward of the hospital, which are usually doctors or PharmDs, or nurse practitioners. They are doing a good job in preventing the new medications being prescribed too much. Over-prescribing new antibiotics can, of course, easily treat the infection right now, but it encourage resistance occurring in the institution. So it's the institution's interest to prevent or reduce the usage of the new antibiotics. So the pharmaceutical companies know this, and they stay away more and more from the antibiotics R&D. Regarding the day-to-day overprescribing antibiotics to treat common cold when it's viral infection, but sometimes patients are so miserable they really hope that their doctors would prescribe some antibiotics for them just in case there is bacterial infection superimposed on the original viral infection. Then they're naturally a very common practice, no matter how much doctors try, to not prescribing antibiotics to patients with viral infection, but sometimes patients really, really ask for it. And when doctors themselves are not able to convince the patients, or they are not sure really if there is bacteria superimposing the viral infection, they prescribe the antibiotics. And the patients may take a 5-day, even if it's really a bacterial infection, the patient may erroneously take only 2 to 3 days of antibiotics. When they feel better, they stop the medication, as opposed to taking this prescribed 7 days or 5 to 10 days course. So that reducing the duration of the antibiotics usage on the patient's part encourage resistance. And these resistance would flush down the toilet, from patient's feces or urine, and flush down the toilet and get into the sewage system and go into the soil. The contaminated environment, and if you include the drug manufacturers in some third world countries such as China or India, they may not have a very strong environmental organization to regulate their factories. All the factories are not observing the law or the regulations that much, so they can have massive amount of antibiotics being flushed down to the soil, to the river. And when these resistant genes are in the rivers and soil, they're shared among the bacteria and fungi themselves, and to the point that not only patients but healthy people who are colonized with these resistant bacteria are everywhere. And these sewage system, this farming practice, this drug producing factories, they harm their community, the people living in their community and far beyond their community because of the river. And in some countries, again, the third world countries, the hospitals may not even have antibiotic stored who are in charge of the proper usage of antibiotics in that hospital or nursing home. The contribution from the healthcare people in the spread of antibiotic-resistant superbugs are not small, but compared to the commercial agriculture, farming, and drug-producing factories, it's not a large scale. And the meat-producing animals, they use a lot more antibiotics. There are some orange groves would use syphilis drugs, tuberculosis drugs to cultivate the oranges, to kill the microbes in the soil. There are powerful lobbies are working every day to maintain the usage of such antibiotics, such as the syphilis drugs or TB drugs in growing oranges. There are fungicides being used in tulip gardens in Netherlands or Central America. When I went to Ecuador, I saw the rose gardens are using antibiotics. The healthcare overprescribing compared to these are really a small scale. And there are some diseases, such as dermatologists using antibiotics to treat rosacea, or there are some infections, say, in the spine. They need to use lifetime suppressive low dose of antibiotics to prevent the spread of the infection from the spine to somewhere else. Or there are the cystic fibrosis patients who will need long-term antibiotics, a burn patient. So there are conditions in healthcare that we have to use antibiotics for long-term. Not all antibiotics being prescribed long-term are inappropriate prescribing. The fourth question or fifth, I don't remember, that you asked me is, how much influence do you believe the U.S. healthcare system has had on creating the antibiotic crisis? I think I already answered some of it above. And the next question you ask is, overprescribing antibiotics a significant contributor to the bacteria resistance crisis? Yes, I also answered that above. But let's talk a little bit more about the U.S. healthcare system, if there's a way to the regulation changes or strategies to help to alleviate this crisis. Well, one is what I talked about, the stewardship. Each hospital, nursing home, skilled nursing facility, they should have antibiotic stewardship to oversee and prevent the overprescribing or using too strong antibiotics when it is not necessary, when a lower tier antibiotics can do the job. Another is that when I talked about those pharmaceutical companies' resistance or reluctance in spending money on R&D to produce antibiotics, there are many regulation alternatives or strategies are being discussed at this time. One is public funding or giving pharmaceutical company tax incentives. There are many potential antibiotics there can be researched upon. It's just not mature enough to be used in clinical trial, but we just need some drug companies take on the task. There's a proposal, it's called social subscription, that is to have a global collaboration between US and EU to share their new development and have a subscription. That means the drug companies can have access to those preliminary medications so that those companies do not need to spend money at the very basic level of research. In that way, the drug companies will not only stay in the therapeutic space of the medications that are financially rewarding to them, such as heart disease or cancer drugs. If they are able to have access to those preliminary drugs, then they save a lot at the early stage of research. And if their antibiotics would not, even though if they're not selling 10 or 20 billion per year, like heart disease drugs or cancer drugs, they may be satisfied with selling a few $1 billion a year on this antibiotics because their R&D are not that heavy in terms of investment. But soon after this proposal was mentioned, the drug companies say that they probably would need even more incentive, not just these social subscription, but the tax incentive. The example they use is that when they sell a blockbuster medication, if they can be taxed less, they are willing to use those saved taxes to the antibiotics R&D. So the government also is using this as an enticement. Right now, the government's participation in terms of funding in new drug development is not a brand new idea, really. There are Orphan Drugs Act that have produced hundreds of drugs that using the tax incentives that the government would save the drug companies about 50% of the expense toward phase 2 and phase 3 clinical research. These monies are covered by public funds. The NIH and many universities, their grants are using this to produce many orphan drugs. These are good examples, are successful examples in producing certain rare cancer drugs, are not still very welcomed by drug company to produce antibiotics because there's this big elephant in the room that's called antibiotic resistance. It only takes on average about 5 years or sometimes 8 years to have antibiotic resistance. And the drug companies still not, they still feel that not able to have a long enough time to regain or to make enough money to cover their R&D investment. Another reluctance, another reason for the drug companies' reluctance of producing antibiotics, one is the resistance I mentioned, the other is stewardship. And as I also talked about, all institutions, good institutions, responsible institutions, when they use antibiotics, they have a firewall or stewardship that limit the antibiotics overusage. So far, there's not a lot of strategies are effective enough to convince the drug company to produce antibiotics, and therefore there's another voice saying that we should nationalize antibiotics production because antibiotics is a public good, just like water and electricity. Then a society, a government, a country, or the whole human race should pool their resources together, make the antibiotic production government project and no longer in the private sector. And this naturally is not welcomed by people who are suspicious of the government in general. Most of the time, people do not, at least in America, people do not want the drug production becoming a nationalized industry because it's being seen as inefficient or even counterproductive. Other regulations include giving tax incentives to the companies that research the new diagnostic techniques so that they can allow doctors to make accurate diagnosis of an infection rapidly, as opposed to nowadays most of the time we're still using pretty old-styled way of culturing bacteria or fungi on a petri dish and then give these cultured organisms different antibiotics to test their sensitivity or resistance, and this process takes a few days at least. And these are the time that patients and doctors do not want to wait. The symptoms are so severe and the threat of spreading over this 24 hours to 72 hours is so grave that both patients and doctors want to go ahead to empirically prescribe broad-spectrum antibiotics to cover all possible organisms first. And this naturally encourages a lot of antibiotic-resistant organisms occurrence. So the diagnostic techniques are the front that we really need to improve. Hopefully that would be a day that is just like doing a CAT scan or MRI, seeing images of the part of our body. We will be able to use immunology or more of the molecular way to diagnose microorganism infections. So their proposal of the government should provide heavy tax incentives to the high-tech industry to produce those diagnostic methods, not just a drug company to produce antibiotics. And the last proposal is that helping the researchers to seek the needles from the haystack. That means when I talked about how prevalent the naturally occurring antibiotics exist in the soil, in the water system, we need a more effective way to find these naturally occurring antibiotics. The current way of finding them out is too slow, and hopefully using the big data or artificial intelligence, they're able to sort out the useful antibiotic materials that occur in our natural environment, to use them, or gene editing to make them useful medications. And their proposal of the government doing that part of the job, and when they find something that are hopeful, then they provide to the drug companies free of charges. And earlier when I mentioned that there's in general underreporting of the superbugs from the hospitals, or in the campaign trail, I heard one candidate mention that there should be a federal mandate for all hospitals report superbugs, because currently the regulation varies from state to state. So there's lack of transparency, and the CDC and NIH are not able to get sufficient information in the occurrence of the superbugs, and therefore not able to devise a strong containment strategy and protocols. All of these above mentioned potential regulation or strategies really requires a strong political will and public discussion during this campaign season on the campaign trail. I talked about antibiotic-resistant superbugs really from the perspective of a first-line medical worker, a doctor who's seeing patients, doing bedside patient care day in and day out for 25 years. However, I am a cardiologist, and my expertise are in cardiovascular diseases. But since the superbug is such a major threat to our overall health and survival of human beings, and if we don't deal with it effectively and soon enough, then we will be looking at, by 2050, there will be more people dying from drug-resistant organisms than from heart disease and cancer. And so it's a serious problem, and we should have a stronger political will to devise and have a collaboration between countries to deal with this problem, so that we don't get into this post-antibiotic era when simple skin infection, simple injury, or simple surgery can mean the death of a person because of infections can spread so rapidly. So I hope this helps.